thank you everyone for joining us. My name is John Van Nostrand and I'm with FLEXIM now for almost 12 years. I am the water, wastewater, and power market specialist for FLEXIM. I've been in the industry for about 35 years. Prior to FLEXIM, I was with Anderson Hauser as product manager for pressure and temperature. Before that, was also a field representative. So I'm happy to be providing this webinar today, and I'm just going to go right into what we're going to talk about. And we have a little bit of shared presentation today with Mr. Dan Hines, which I will hand over in just a moment. And he'll do a little introduction about himself and about Cross Company, who is our representative for FLEXIM. So the goal of the presentation is to facilitate recent developments in ultrasonic measurement from FLEXIM and to familiarize you with the reason why FLEXIM is the best choice for new meter installations and retrofits, especially those where Magmeters are concerned. So Dan Hines will go over some interesting facts about the Cross Company, and then I'm going to go through a little bit about the FLEXIM company and the theory behind the measurement, FLEXIM meters that are used in water, wastewater applications and in industrial applications, and why FLEXIM is successful in areas where others are not. Dan?
Yeah, good afternoon, everyone. Thank you so much for joining the webinar. We just wanted to give you just a quick thumbnail sketch of how and why Cross Company is here. We're proud to be affiliated with FLEXIM. Our company is a leader in flow measurement solutions for customers. Cross Company is based in Greensboro, North Carolina. We are a 100% employee-owned company, so every one of our near 700 associates own the company. And we survive and thrive by providing incredible solutions to customers' problems, bringing value to customer, helping them improve their safety, their process throughput, their profitability, or reduce costs. We do that through 5 independent operating business groups. Our team is the Process Solutions Group. We're a certified CSIA system integrator. We have a UL 508A panel shop where we build our control panels. And then we are very well versed in flow measurement applications. And we wanted to share this information with you because of the many successful applications we've deployed with the FLEXIM ultrasonic clamp-on meter technology in places where water and wastewater, municipal or heavy chemical applications have required an immense investment in just taking the old Magmeter out to put an egregiously expensive one back in. And so John is going to share that with you. John, that next slide will talk a little bit more about our particular efforts in the field for our customers. We provide not only the product solution, but we can help design a system. We can help you bring it to life. And then we have a field service team with service engineers and service techs, where we can bring our meters from FLEXIM online, help with flow verification and validation steps going forward. One more, John. And I mentioned that Cross Company is 700 strong. Our group, the Process Solutions Group, we have 59 associates, and we're spread all over 8 states plus the city of Philadelphia and the District of Columbia. And we're super happy to be affiliated with John and the FLEXIM team. And I'm going to turn it back over to John. And this should be very, very enlightening for you. Thanks, John.
Thank you, Dan. Appreciate that. So a little bit about FLEXIM. FLEXIM is a wholly owned subsidiary of FLEXIM GmbH. So the FLEXIM Americas group there, shown on the right, is based in Edgewood, New York. This is a 20,000 square foot facility where we service all of the Americas. So there we have sales and marketing, R&D production, calibration, and service. We also have offices in Illinois, California, and Houston, as well as representatives around the country. So the FLEXIM company manufactures a number of different meters. The 4 series and the 6 series are the portable meters that can be carried out into the field for spot checking and for temporary service, as well as verification and calibration of other meters. And then the permanent meters are the 5 series and the 7 series and the 8 series. That's ideal for class 1, div 1 locations. And we also have the 7 series that's ideal for class 1, div 2 locations. Training and knowledge is really important, and FLEXIM is dedicated to sharing that knowledge in a number of ways, like individual trainings, like these types of webinars, for example. And we can put together training that's specific to the needs of your team. We offer training at our factory in New York, and sometimes at your facility, even in a virtual environment. So we also prepare webinars to share knowledge and participate with multiple conferences throughout the year. So let's jump right into how the meters work. Transit time meters, as the name implies, measures the difference in time travel between ultrasonic pulses that are transmitted in the direction of and against the flow. So this type of meter can also be called time of flight meter. We tend to call it, or time of travel. We tend to call it transit time. And basically what we're looking at here are 2 individual signals. And these signals are the top one represents the transmit upstream signal. The bottom one represents the transmit downstream signal, and it's the difference in time between the 2 that we're looking for. And that transit time difference is proportional to the velocity of the media, and we know the diameter of the pipe and the characteristics of the pipe, so we can then calculate volumetric flow. So one of the biggest advantages of clamp-on ultrasonic flow meters that can be installed to meet the exact needs of your system. So these devices can be permanent or portable, and it makes that very flexible as a measurement tool. So they can be used, in a permanent type of location, or retrofitting existing metering points. For example, if a Magmeter fails, you can very easily install a FLEXIM meter in its place using the existing power and signal wire, and you have an accurate flow measurement in a few hours without any downtime at all. For new installations, there's a cost savings as well, and that's pretty significant because there's no need for bypass piping or conical reducers to increase velocity of the media through the meter. For example, an oversized pipe with a Magmeter. The FLEXIM meter is capable of measuring extremely low flows down to 0.03 feet per second and extremely high flows up to 80 feet per second, and there's no need to ever cut the pipe. So the reason I'm saying this is because the Magmeter has a sweet spot from 3 to 33 feet per second. And below that and above that, it'll still read, but that's where it's most accurate. So below the 3 feet per second, the accuracy can begin to degrade slightly, and as you go lower, it also becomes more pronounced, where the FLEXIM meter can go down to 0.03 feet per second. So there's no need to do the increased velocity through the meter. The 721 clamp-on flow measurement solution is the workhorse for us. And essentially what we see here is this is an indication of what the meter actually looks like. It comes with a wall bracket that can be mounted onto the wall, and then the meter mounts right onto that. It's very simple. It does bidirectional flow, and it can be on any type pipe size, any type of pipe as well. So it can be anywhere from stainless steel pipe to plastic pipe to fiberglass pipe, HDPE pipe, even concrete pipe. We're able to measure flows in concrete pipe. The secret is that we want to have a full pipe, because we're going to do our math based on the area, dimensional area of the pipe. So we want it to be full. So there are a number of factors that have helped FLEXIM become very successful. And these are things that are designed into the FLEXIM solution. And these are things that no other manufacturer does. And this really sets us apart. For example, using coupling compound as as a medium to move the signal through the pipe wall without using the grease. This means that there's no maintenance, so there's no reason to ever go back and recouple the transducers. It's intended to be set it and forget it. We calibrate every pair of transducers that leaves the factory. That means you don't have to start the meter and obtain a zero flow and tell the meter in the field what the 0 point is, and as that acts as a calibration. And we don't have to do that because we know that it's not possible most of the time in order for you to even obtain zero flow. This is something that that other manufacturers will have to do. So we also match the transducers. We call that wetting. We have a lot of wettings at FLEXIM. And essentially that just means that we're matching the upstream and downstream crystals inside the transducers to ensure that they have the tightest accuracy. We also integrate the cables into the mounting so that it's a robust solution and there's no upstream, downstream connections on the cables. They're already integrated, and it's those cables are a weak point for our competitors as well because they tend to break. Some manufacturers even brag that they use gold plating on the connectors because they know it's a problem with corrosion and so on. With FLEXIM, you don't have that at all. We also offer variety of types of transducer frequencies like Lamb wave and Shear wave with 1 meter. And that means that you can measure liquids or gases, or even Doppler type slurries where you use a Doppler meter, which we'll get into in a bit, and even steam. So you can do this all with 1 meter. So we also temperature compensate every pair of transducers that we deliver. If temperature compensation were not built into the transducers, that shows up as an error and as drift in the measurement. So with temperature compensation, that gives us a very stable reading across the entire flow range, including 0, even at the 0 point. The meters are bidirectional, meaning that you can flow forwards or backwards without making any changes whatsoever. So the coupling compound, it seems like my link is broken here. I would normally be showing you a picture of what that transducer looks like with the coupling pad on it. But essentially what we have is a Viton pad that fits on the bottom of the transducer, unlike our competitors that use a grease that has to be maintained. You have to go back and recouple that every once in a while. Otherwise it'll fail and then you wind up chasing failures. So that means basically 0 maintenance once you install it on the pipe. So calibration is important, and like I mentioned earlier, we calibrate every pair of transducers to a NIST traceable 17025 standard, and other meters would require that you calibrate in the field by setting a 0. And there's so many places that you're unable to do that. What most manufacturers will do is even skip that step, and there's no calibration at all. So the issue is that you've got drift in the measurement, and now you're not even doing a 0 point calibration. So any error that's in that transducer is going to be transmitted into your output. So what I will state to you is that when we install our meter on the pipe, you're going to get a 1% accuracy, and that's of the indicated value. And the repeatability is 0.15%, and the reliability, of course, is 100%. So at FLEXIM, I mentioned also that we do wettings. We match the piezoelectric crystals so that they have the tightest possible accuracy before they even go to the calibration rig. So when we match the transducers, essentially what we're doing is we're making sure that this frequency of the upstream and the downstream transducers have a very, very tight tolerance. And that gives us the most stable measurement possible. So we integrate the cables. I mentioned that we don't have the up and downstream cables and the BNC connectors and the RG connectors and all the different types of connectors that all leak. They all are not waterproof. The FLEXIM meter is an IP67 design, and we also offer IP68 transducers. This means that once you install them on the pipe, they're going to operate for years to come without any maintenance. So we offer the two types of frequencies for whether you're going to measure liquids or gases. And that can be done, as I mentioned, with the same meter. It's just a different set of transducers. And one is called the shear wave and one is called the Lamb wave. Well, the Lamb wave is typically used for gases and the shear wave is typically used for liquids, although there are some exceptions. The best way that I would like to describe it would be is if you've ever been to a wedding and somebody stood up at the head table and gently tapped their wine glass and everybody in the room could hear it. That's exactly what we're doing with the Lamb wave transducer. We're actually resonating the wall of the pipe. So when we look at measuring gas, we typically want to match the transducer to the pipe wall. That is to say the thickness of the wall versus the frequency of the transducer. And with the shear wave, if you were to pour out the Riesling in your wine glass and fill it with Guinness beer, you could wrap it with your butter knife and you wouldn't hear it yourself, most likely. In that case, what we would want to do is we would want to penetrate through the wall of the pipe to the other side. And we do that with the shear wave, meaning that we have a focused, narrow focused beam from one transducer to the other. So in this case, it's not so much about the wall thickness of the pipe, but more about the diameter of the pipe. And so if you were to visualize the energy between shear wave and Lamb wave, I would say that the shear wave looks like a spotlight, while the Lamb wave looks more like a floodlight. But the interesting thing about this is that FLEXIM is able to do both, where most manufacturers do one or the other. If you take, I can think of manufacturer A that uses shear wave only, and manufacturer B that uses Lamb wave only. Manufacturer A has very little success in compressed air and steam and gas applications, and vice versa for B that can't really do liquids that well. So the nice thing about FLEXIM is that we're able to do both of those. Now I like to show this slide because it illustrates the RTDs, the temperature sensors that are inside of the transducers. So what we're doing here is we're temperature compensating the transducer block and the crystal itself. Now, these piezoelectric crystals are very, very much, I like to think of them like diamonds. You know, you can cut them to the same size, you can make them the same weight and so on, but each has their own individual signature. Not to mention manufacturing tolerances, how much potting is being used in the transducer block itself and so on. So any variances between the upstream and downstream should be calibrated as well. And that's why we do that before we ship our transducers out into the field. Best possible accuracy. Now it's worthy to mention that ASME wrote a standard for temperature compensation, and it's called MFC5M. And FLEXIM is the only manufacturer that meets that standard. It's really important. So another amazing technology difference with FLEXIM clamp-on meters is the digital signal processing. And here is a leading brand's method. And what we're seeing here is how they digitally impose a marker on the sinusoidal waveform. And through the electronics, this marker is statistically placed on the highest peak-to-peak waveform. And that mark is called the zero crossover. So there's an electronic detection window where the digital mark should appear. So let's face it, if they send 100 digital pulses and they receive 50, the math is easy enough. They've got a 50% signal strength. Sometimes though, when the process changes after you've started up the meter, that digital mark can move because that highest peak-to-peak sinusoidal wave value can move. Therefore, the highest peak-to-peak zero crossover will also move, and it can move right outside of that detection window. So when it does, if it moves outside of that detection window, I hope you can see my pointer. What happens is you get a fault. You get a lost signal or low signal or detection fault. One manufacturer calls it that. But nonetheless, it stops working and that signal is still there, but the meter can't see it. So what I'd like to point out here is what FLEXIM does is that we have what's called a signal envelope, and we actually encompass the entire signal. So with the FLEXIM technology, we actually place 8 digital marks on each sinusoidal waveform and count them all. because like I said, that detection window encompasses the entire signal. So now not only do we have the signal strength, but we also measure the fidelity of the wave. We've got a quality measurement. So FLEXIM uses twice the transmit voltage as our major competitors as well. So in other words, with higher signal amplitude, we are able to measure on really tough pipes that would otherwise be impossible. For example, if there's sludge lines or ductile iron, cement line pipe, or even precast concrete pipe, we can measure those. When we start up the meter, we look at the SCNR and we can look at the signal to correlated noise ratio. And there are a lot of diagnostics that we look at to ensure that we've got a good signal and that we're accurate with our pipe dimensions. And once we've established that, we can then trust the measurement and that the calibration of the measurement is going to get us that 1% of the indicated value. So it's important to note that, you know, we're active with AWWA, and we know about M36, which is the Handbook for Resource Management, and we're very familiar with that. M36 calls out the use of ultrasonic flow meters. The C75019 covers transit time flow meters and closed conduits. I'm very familiar with this standard. I'm actually the chairman for the subcommittee at AWWA. And then the AWWA C715 standard addresses the requirements for revenue generating meters, and FLEXIM is fully compliant with these standards. And our aperture calibration method is also accepted. So calibration is the next topic, and it's important to us, and we calibrate every pair of transducers and meter that we ship on our flow rig in New York. So this is a traditional method for calibration. This is called the comparative method, where we're going to put a master meter in line and then use a device under test, which would be the production meter, that will compare to the master meter to see that it passes calibration. Well, this is something that FLEXIM has developed as well. This is called aprical, and this is a new calibration for FLEXIM in the last few years, and FLEXIM has pioneered this and made it available to the open market as well. So the conventional calibration, like I mentioned, compares the device under test with the reference instrument on a wet flow rig. However, the flow profile in every flow rig is influenced by pipe characteristics and the installation conditions, which leads to uncertainty. With the FLEXIM aprical, this is a patented traceable aperture calibration method that examines the time difference between the upstream and downstream. And what we're actually doing is we'll put these in a bath, and then we'll move one of the transducers ever so slightly to simulate that time difference, which would then translate to a velocity. And this is a very accurate method. We're getting down to 0.3 measurement uncertainty, but we still specify plus or minus 1% in your application because your pipe conditions vary. We also calibrate every transmitter before it leaves the factory. This is an electronic calibration, and what you'll get when you receive the meter is you'll get a calibration certificate for the electronics as well as for the transducers. And this is a nice thing because now you've got a pair of transducers and a meter that are both calibrated but don't necessarily need to be used together. So when our competitors do calibration on meters, they actually have to mate them together, do the calibration, and ship them together, and that's how you have to use them and install them. With FLEXIM, we calibrate them individually, and the transducers carry what's called a sense prom, and that little sense prom is this EEPROM on the lower left-hand corner here. You can see a picture of it. That plugs into the flow meter when you install the transducers, and now that calibration is mated to the flow meter as well as to the transducer. So the calibration factor for the transducers resides on the sense prom. You plug it into the meter, and now you can use those transducers with any meter. The question often comes up about how many straight runs are necessary. The installation recommendation for direct mount transducers are opposite each other on the pipe are 5 diameters downstream and 10 diameters upstream of an elbow. And many piping systems don't allow for those 15 diameters of straight run. So FLEXIM has performed independent testing with reflect mount where averaging takes place. And then we can reduce that straight run requirement. But then we also have something that's called profile correction. And that profile correction is something that we've learned over the years. We know how flow profiles behave from the introduction of upstream disturbances. As a result, we now have this feature that we can turn on for profile correction, and we can program the distance from the meter from the elbow that's upstream of it and do a correction. So we've done a lot of testing, and this testing has proven that we can be accurate downstream of an elbow, downstream of 2 elbows, and 2 elbows out of plane. We're also working on 45-degree bends currently. It's a terrific feature, and it's in the 721 and in the 532. So in the 721, under special functions, we just basically turn on the expert user mode, and then it gives us that feature, and all we'll need to do is put in the distance to the bend, to the center point of the transducers, and the meter does the rest. All the math is adjusted for that upstream disturbance, and the algorithm is activated. So FLEXIM offers a unique feature called noise check. I mentioned Doppler a few minutes ago, and Doppler is essentially the old style of ultrasonic flow meters, and essentially it's for if there's a lot of solids and air bubbles and things like that in the media, so much that the transit time doesn't work, then we switch to Doppler. And essentially what we're doing here is we're looking for frequency shift in the media, and that frequency shift then translates to velocity, and we can calculate volumetric flow from that. The problem is these receptors, these little particles that are moving through the media, are moving very violently as they're moving down the line, and they move up and down and forwards and backwards in all kinds of different ways. So the issue with Doppler is it's not as accurate as transit time. However, we would still expect to get 3% thereabout, 3 to 5%. And the nice thing about this FLEXIM meter is if you run into a situation where Doppler is required, the meter can actually automatically go into transit time and Doppler and switch over from one to the other as necessary. So you're in transit time mode, you remain there, and suddenly you have a lot of solids or some air through the line. The meter will say, okay, now let's switch to noise track, what we call noise track or Doppler, and then it will operate, and it'll continue to look back to see that transit time can be used again, and once it can, it'll automatically switch back. And the reason we do this is because, like I said, transit time is more reliable and more accurate, and therefore that's what we would prefer to use. There are also applications where Doppler seems to be the better method, and we can operate in that way at 100% of the time. So it's very flexible when it comes to that. So the Fluxus 721 is the ideal meter for industrial applications, and it can operate from about 1/2 inch, 3/8 of an inch, all the way up to 144 inches. I have done myself. So large or small, the meter is the same. The transducers change accordingly for the application, and we can handle up to about, well, we have, so it's called a wave injector that will take us into cryogenic applications, as well as 1150 degrees Fahrenheit that we've done now. So the standard range might be 266. However, we can go much, much higher. So the portable meters are terrific and can be used to verify calibration of other meters in the field. They can use they can be used to spot check they can be used for leak detection, for pump performance, valve testing, valve leak by, etc. And the nice thing about the F601 meter is that everything you need is in the case. You get the portable meter with 2-channel capability. Optional wall thickness gauge is in there, so you can actually put the wall thickness gauge against the pipe, measure the wall thickness of the pipe to ensure that you know that the schedule of the pipe and the diameter and the wall thickness, all those come into play, and it makes it very, very easy to program. It has data logging capability, and the software is included in the package as well. The 401 is designed really for water wastewater industries, and it's really excellent for leak detection systems. It's ideally suited for monitoring drinking water networks or very basic water flows. It doesn't have a lot of chemical tables built in like the F601 would. Industrial chemicals and all are built into the F601. The 401 is primarily used for water and basic flow measurement. So essentially what we've done here is with the technology improvements that we've engineered the drift out of the measurement. So we verify the meter is set up properly during the installation by measuring the sound speed of the media and ensure that that matches that what we would expect. As an example, if we put the pipe on a water line that's 70 degrees, we happen to know that the sound speed of water at 70 degrees is about 1480 meters per second. We put the transducers on the pipe and we get 1480, then we know that we've got it set up properly. We put the transducers on the pipe thinking it's a schedule 40, but it's really a schedule 80. That pipe wall thickness has a much different sound speed than that of water. So the sound speed that we measure may not be what we know it should be. So with that in mind, then we have to start thinking, what did we do wrong? Did we get the transducer spacing right? Did we get the wall thickness correct? And did we get the diameter correct? And if we've done that, usually the only wild card would be that wall thickness. So once we get that programmed in properly, we get the proper sound speed. Now we know that we can trust the meter calibration. The ductile iron pipe that I'm showing here has a sound speed of about 5,000 meters per second. Then if you had a concrete liner, that has its own sound speed as well. But ideally what we're looking for is we're looking for that 1490. So we want to make sure that we have all the parameters set up to ensure that we've got that value. And that's a key diagnostic. Once we set it up and we have the right sound speed, now we know, we trust the measurement, and we're off and running. So once we verify the meter is set up properly by ensuring the sound speed that matches what we expect, temperature is also correlated with the sound speed of the media. So if the temperature changes, so does the sound speed. And we can actually calibrate the meter on water applications very easily. We calibrate the meter for any change in sound speed. So when we set it up, we know the water is 68 degrees, for example. We get the proper sound speed for 68 degrees, we can report that number. So now the meter can actually use the sound speed to report the temperature of the water. It's a very unique situation there with the sound speed measurement. Nobody else can do that. So this matrix shows the difference between the 721, the 501, the 532 rather, I'm sorry. The 532 is the water only. It's really designed for water wastewater applications. The 721 is more the industrial style meter. The accuracy is very similar. The differences could be the transducer selection, and the 721 has the ability to do multiple channels where the 532 is a single channel meter. This shows the Permarail track mounting system. This is what comes with the WD meter and is included as part of the offer. And you essentially mount those base track to the pipe, and then the overlaying track fits inside the base track, and it makes a very easy installation. It's also very robust. It'll last for many, many years. So advanced metering verification, or AMV, is our integrated verification tool. And AMV helps to ensure that the measurement system is meeting the requirements. So what we're doing is when we first install the meter, we'll set up the advanced meter verification. And then essentially what you get when you come back is you'll get a predictive maintenance report. So initially, you'll have the installation report, and this is a verification that the installation is done properly and that the diagnostics fit the requirements for the measurement. And then it will print this report to give you the indication that everything is done properly. And then if you come back, I don't know, 6 months or a year later, for example, and you want to verify that nothing has changed, we can do that by just running this report, and then it gives you the red light, green light, yellow light type of thing. And it shows the tolerances and so on. So you'll basically get a full-blown report to say that the meter is installed properly. And when you come back to run another report, you can see if anything has changed and if anything needs to be done, like calibration, for example. So the meter verification virtual technician tool, essentially what this is a tablet that enables you to go out into the field with a hotspot, has the software for the meters already preloaded on it. Sometimes there are problems with IT being able to load software onto your computer and so on. So we offer this little tablet that kind of acts as a interface for FLEXIM meters. And with that hotspot, you know, even through a cell phone, for example, our technicians can dial in and assist you from anywhere in the world to anywhere in the world. I do have a few. This is just an illustration that shows the virtual technician tablet being used to connect with the USB and a hotspot and remote operating the flow meter. I do have some utility references from around the country. We're not limited to these, but they're kind of everywhere, and there's some popular utility companies that are FLEXIM users and have been very happy with the results that they've gotten using FLEXIM. Like I said, we're not limited to that. These are some applications, and this particular one is a drinking water application where the transducers were buried directly in the ground. The first one on the top picture was a 24-inch cement lined ductile iron pipe. And then the one on the bottom is a 30-inch carbon steel pipe. In both cases, the transducers were backfilled with no further concerns. So we had customers that require, you know, to measure pipes that are underground, and they didn't want to put in metering vaults, or they couldn't, or maybe the location was wrong, or they're expensive, or what have you. So we basically buried the transducers directly in the ground. Worked out extremely well. This utility is in North Texas, and they were faced with a problem because they have very old precast concrete pipe, and they were looking at a very expensive solution to replace old Magmeters. These were Fisher Porter Magmeters from the 1970s that have failed, and they would not be able to be serviced. So essentially what we did is we went and showed them that we were able to do this. And so they were looking at 6 lines where they would have to remove the roof of the building and use a crane, cut the pipes, remove the old meters, put new ones in, flanging, etc. This was going to be a multi-million-dollar project that would take a very long time because they'd have to have the plant shut down and so on. So we went in and actually installed this first one before lunch and saved them millions of dollars. It's astonishing. So lead and copper is another thing that's really important in the water wastewater market, especially in drinking water applications, where it was originally established as an initiative in 1991, and then there's some things that happened. I think everybody might know what happened in Flint, Michigan, and that initiative quickly became a rule. It became law. And so essentially what they've done is they've changed the action levels now from what was 15 parts per billion to 10. And if there are 10 locations that sample higher than 10 parts per billion, then they must do something to resolve the lead and copper in the drinking water. And what they wind up doing is they wind up, of course, putting orthophosphate into the line to coat the insides of the pipe. And of course, what that does is it fouls the magmeter, because it coats the inside of the magmeters as well. So magmeters just fail, and they would have to be removed and cleaned. And it happens often because they're continuously coating with orthophos. This under another circumstance is that if there are iron oxides in the water, manganese, for example, here's a picture of what magnetite coating would look like under a microscope. And so what happens is these are microparticles. This is under a microscope. Like I said, it kind of reminds me of what ceramic looks like, but it's black instead of white. And so ceramic is aluminum oxide. This is iron oxide. So each of those little particles have a north and a south pole, and they wind up sticking onto themselves, and they coat the inside of a pipe. So if you've ever taken a well apart, for example, and you have like a black film on the inside of the pipe that almost feels like a little bit greasy, like a grease on your finger, or you get it on your clothes, it'll stain. That's what this is. Or if you see there are red sidewalks where people are watering their lawns, or if there's red staining in the bathroom sink, this is a real problem for those utilities, and they may not even know it. So we did some testing on a well, and in this case, what we see is about over 2 years. This was a Magmeter that was installed, and at the same time, FLEXIM was installed. So the orange line is the FLEXIM meter, and the blue line is the Magmeter. Over time, it started reading lower and lower and lower, and the FLEXIM meter read the same. And what it was that they had manganese on these wells, and essentially what's happening is it's bridging the electrodes. So that iron oxide coats the inside of the pipe and creates a short from one electrode to the other, causing it to read lower over time. And they would have to go and roll the meter out of service, reach inside of it, clean the electrodes, because the electrode cleaning circuit was powerless against this manganese. So they would have to physically clean it, put it back in service, and it would operate again for a while until it started reading low. They couldn't continue to do that. They had 12-inch wells, and there were hundreds of them in the well field. So they decided they were just going to use FLEXIMs, and we put meters all around the well field as well as in the distribution, and it resolved all of their imbalances. So now they have no more problems with water balance. It's no longer an issue. So we assist a lot of utilities, and what we've learned is that most drinking water piping systems flow below 3 feet per second. You remember what I said? Magmeters like 3 to 33 feet per second. Well, off-peak times, the flow diminishes to velocities that are even below 0.26 feet per second, and sometimes the flow even moves backwards. So with low flows like these, it's nearly impossible for conventional flow meters to capture the movement of the water. At FLEXIM, we can do that. So this is a typical underground installation, and although we always recommend measuring above ground, it's not always possible. And sometimes the transducers need to be buried directly in the ground. I showed you a picture before of a couple of them. It's not a problem with FLEXIM, and we actually have a method where we can install the transducers and bury them directly into the ground. And look, I like this one because there we are replacing another transmitter, a Magmeter. So another underground installation, and you can see here we've got, this is Citizens Energy in Indianapolis, and they've got a wastewater treatment plant drain flow meter. This is a very interesting application. I thought that the flow is actually going down. We typically we'd like to measure when flow is going up, but as long as it stays full, it's not a problem at all for us. We just need to have a full pipe, and it'll work just fine. So this is another typical underground installation. And here we have HDPE pipe. And again, it's not always possible to put a vault in. So we essentially put the transducers right on the pipe, protect them, and then backfill it. A 12-inch drinking water production well. Here we have stainless steel piping with CDM transducers. This is a very common application. This is well water, and it has heavy manganese. So this is one of the examples of the utility that I mentioned earlier that was having manganese issues. This is one of the wells. Here we have an 8-inch sewage lift station. So clean water, dirty water makes no difference to us. We still operate in transit time. This is a new construction project. They don't use Magmeters anymore for new construction. They use FLEXIM meters, and again, they save a lot of money and bypass piping and so on. This is a wastewater application where there are transmitters at the top of the headworks, and I think that they put them up there because they want to be able to adjust the knife gate valve on the weir and see the flow while they're doing it. But the flow is actually down on the ground. You see the red circle matches the flow meter transducers, and the blue circles match train number 1 and train number 2. So they have 2 treatment planes at this plant in St. Augustine, Florida. And these are 20-inch ductile iron pipes. And again, this is how they control the plant. It works out very well for them. So this is a utility in the Northeast with very old infrastructure that dates back to 1857. Now, I don't believe this pipe is that old. However, it is quite old. And this is an interconnect with Greenwich, Connecticut, where water is being sold to a utility in New York State. It's a 16-inch ductile iron pipe with a cement liner. And the company was using turbine meters for billing and was missing. And they have very precise meters, and they send them out for calibration regularly. But the problem was that the revenue was down because during off-peak times in the middle of the night, those turbine meters would not move. They wouldn't capture low flow. Because of the need for greater accuracy, we used 2 sets of transducers. We did a test with the utility, and multiple propagation paths was a good idea because of the piping limitations that we had. And essentially what we've done is we've been able to capture that revenue that they were unable to capture before. This is a utility where our technician walked right up to a pipe and wanted to do a test against a Magmeter, and essentially what you see is a meter that's spot on. And we obviously the Magmeter passed the test for calibration, but this is how our portable meter is often used to verify other meters. The customer installed a magnetic flow meter on a sodium hypochlorite line for dosing, and the magnetic flow meter didn't really stand a chance during off-peak times because the flow was so low the Magmeter didn't even register at all. And as you can see, the comparison between the Magmeter and the FLEXIM meter in the picture, you can actually see that's very, very low flow. That is a 1-inch Schedule 80 PVC that's flowing 2.8 gallons per hour, which is 0.13 feet per second that we're measuring. Now, our meter is accurate to 0.3 feet per second, like I mentioned. It still operates down at 0.13. Again, the accuracy may be a little bit less because we're outside of the spec. However, we're still 10 times able to read above a Magmeter. So it's astonishing what we're able to do with this. Sodium hypochlorite is a pretty common chemical, and it's very common in water wastewater applications and water treatment. So we manufacture a meter that is specific to measure the chemical additive, and we can dose it as well as measure the concentration. You remember I said earlier that we get a very accurate sound speed measurement, and we get a very accurate temperature measurement to correlate the two. Now we can track the concentration strength of the sodium hypochlorite using the sound speed and the temperature. No other manufacturer can do that from outside the pipe. So these are the CDK transducers that are permanently submerged. This is a pretty typical application for a 36-inch carbon steel pipe. This is a pump station that could not be turned off. It is flowing about 20 mgd a day, 20 million gallons a day, going to a plant that processes 50 million gallons a day of wastewater. So it's one of the main pump stations coming into the plant. and they needed to know what the flow was, but they were unable to turn off the flow or turn off the pumps. So the clamp-on was an excellent solution for them. And this is one of many utilities where we were able to get in on an application like this, and then wound up being a standard meter for the utility. Wastewater applications, you don't typically see a DP transmitter with a Venturi, but here's one. And on this was a mixed liquor line. And so they were having issues with the impulse lines plugging and the transmitter fouling. And so we went just downstream and put our transducers on the pipe. And what you see there are two sets of two different propagation paths. So it's two sets of transducers mounted on that pipe and averaging. And they've just done away with the Venturi and the DP. It's now become a system relic. We use the same power from the transmitter that was existing, as well as the signal wire. And again, we were in and out of there in less than a day. Polymer dosing can be done accurately with the FLEXIM meter. And you think of dosing, you think of a metering pump that's pulsating. And that's okay for us because we're averaging about 8 times a second with our signal. So we're able to capture those pulsations. And when it comes to polymer is a very expensive chemical, and they don't want to overdose it if they don't have to, but they do want to flocculate, and they want to be able to settle out the solids in the wastewater. So they use the polymer for that. And there's quite a cost savings by not using too much of it. And the FLEXIM meter was able to help this customer in a big way to reduce their polymer consumption with accurate flow measurement. Like I said, even if it's pulsating and it's very thick and viscous material. So when you look at the differences between the cost of installation between a Magmeter and the FLEXIM meter, the FLEXIM meter installation is really zero. I mean, you're putting the transducer on the outside of the pipe. You might be there for an hour, so you could be looking at an hour labor, where with the Magmeter, if you're going to switch one of those out, you've got to remove the Magmeter, you've got to have calibration done, spool piece installed, you've got to refill the process, you got to be down for a while you're doing this work, and there could be cutting and flanging that might need to be changed because not all takeout dimensions are the same for Magmeters. So it can be quite expensive. And I've seen some estimates that run, this is on a low side, from $4,000 to $13,000 just for the installation. And the installation often is more expensive with a Magmeter than the total cost of our solution. So it's worth looking at for sure. So why is FLEXIM a good idea? Well, there's no need to shut down the line. There's no cutting of the pipe. There's no special equipment required. There's no in-field calibration that's done at the factory. There's no drift. There's no maintenance. There's a reliable, accurate measurement in a very short period of time. And so the other thing I'd like to mention is that with FLEXIM, we guarantee the meter is going to work in the application for which it's intended, or we'll take it back. No other manufacturer will do that either. So we guarantee it's going to work where you intend to use it, or we'll take the meter back. So no meter left behind when it comes to FLEXIM. And I would like to open it up now if anybody has any questions or would like to make any comments. Please feel free.
John, while people are considering an engagement here, could you state again the measurement accuracy of FLEXIM related to the foot per second rating?
So yes, the feet per second value is from -80 through 0 to +80 feet per second. So it's bidirectional. But when we start looking at accuracy, we're capable of measuring down to 0.3 feet per second, 0.03 feet per second, where most meters like I said, Magmeter's like from 3 to 33 feet per second. So we're down at 0.03 feet per second. Now, when you look at other meters where they stop measuring, it's about 0.3 feet per second. So we're actually able to measure accurately 10 times below where most meters stop working altogether. Does that answer your question?
Yeah, it does. And when it goes into bidirectional flow.
Yes, the bidirectional flow can be positive or negative, right? And regardless of the velocity, we can accurately measure it. So you'd have to just think about how you want to span the meter, whether you want to span it through zero, or do we want to have two outputs, one for positive flow and one for negative flow? We can do either. Yes, someone raised their hand. Let's see. I don't really. Give me 1 second here. I'm trying to unmute, but I don't know if I can.
I'll call them out for you.
How's that?
Yeah. So
Courtney,
there you go. You can hear me now?
I can.
I have very application specific questions. Is that okay?
Perfect. Yes.
Okay. We make an emulsion it's about 60% water and 40% it might be monomers or other additives.
Mm-hmm.
Would this work for that kind of application?
What is the viscosity that we're looking at?
It's probably it's just a little more than water, like 1.1.
Oh yeah, absolutely, for sure.
And then the other question is because our polymer coats our Magmeter a lot, so that's one reason we're looking into this.
Right.
But we're a batch system, and so, but when there's no flow, I may have just missed this. What's the meter going to do when there's no flow? Because we need to know when the flow ends.
Oh, so we can actually set an alarm. So when you get to a certain velocity or gallons per minute value, then we can give you an alarm and let you know if you're at that point. It's going to read the most likely you're going to probably have like a 4 to 20 milliamp output from the meter. So at 0, you would see 4 milliamps.
Okay, I just didn't know because you were saying that you needed the full pipe if it was going to cause like some kind of error or issues when there was nothing in there.
Yeah,
okay,
not at all. So now if there's nothing in there and we go into an error, we can actually set an error delay. So we can say if there's no flow at all and we have no liquid in the pipe, show us 3.6 milliamps, for example. So when you see 3.6, then you know that condition has occurred.
Yeah.
Or you could say, just show me 4 milliamps and not worry about it. So there's a number of things you can do to program the meter, so it gives you the right information.
So you were saying that if it doesn't work, we can return it for, because I was going to ask if you have demo units, but if we can just do that, then I don't even need to do a demo unit.
I mean, that's the whole purpose. It makes it real easy for you, and we guarantee that's going to work. What we have is something called a fast form, and that's called a FLEXIM application support tool. It's nothing more than a data sheet. With that data sheet, we look at it and we go, we like this. Our engineer gives it his blessing, and we've done it before. We have good history. Let's go for it, and we don't need to demo it. If it's one of those that we look at and we go, oh, we're not too sure, maybe we should send a salesperson out with a demo and try it. And that's nice about this technology is we can do those things.
Okay. If we were to demo it, we have a pilot line. So it's much smaller piping that would be easier. It'd be easier to demo it on, but it's smaller stainless steel tubing. Do you have units that can go to that small of piping? I think it's 1 inch. I have it written down somewhere. Sorry. I think it's 1 inch stainless steel tubing.
Yes, we can measure 1 inch, but I'm confident that the application is suitable.
Okay.
And what size is the plant going to be when it's built?
Oh, the pilot line is just for our new products, but the plant's already built for
Oh,
a
okay, I
reading of
got
it,
you.
yeah.
All right, so the pipe that we would be measuring on.
I think it's 2 inch. I have to look it
Okay.
up again.
Perfect, yeah. Yeah, we would be able to guarantee that it's gonna work for you. in
Do you
the
need a
end.
certain amount of straight piping before and after? Maybe
We would
certain-
like a total of 15 diameters if possible, but if not, like I mentioned, we have the correction factor that we can use. 15 diameters would be ideal if we can do it.
Thanks.
Sure. Thanks for your
That's-
questions.
Thanks, Courtney.
Thank you.
John, we got two that came in via chat. Todd Dyer asked, can an old mag meter that has failed be left in place and a FLEXIM installed next to it?
Yes, we do that kind of thing all the time using the existing signal wire and power line. Just connect right to the FLEXIM meter, and then, like I said, the old meter just becomes a system relic.
Thank you. And John Lawrence asked, what's your favorite application in wastewater, and any tips on any tips on verifying sound speed?
Okay, yeah. So my favorite application, I love the low flow applications because nobody else can do them, and we're able to. So that's one. And anything where there's like ductile iron, cement line pipe, are a lot of our other companies struggle. We're able to do those quite easily. So I like those. And then the low flows. The second part of your question was, what is the ability on the low end? Is that right?
Yeah, well, tips on overcoming or verifying sound speed.
Oh, okay. Yeah, so when we install the meter, we actually look at that sound speed value. So you can do that just by toggling the bottom line display, hitting the number 3 key, and you would just press that 2 times and it'll show you the sound speed of the media. And then we verify that with what we know to be true. And now I think part of the question might be, how do you know what the sound speed is of the media that you're measuring? There's a couple of ways to go about doing that. First of all, we have a library. So our technical group has a lot of experience, and we would just consult with them and say, what sound speed are we expecting? That's one way. Another way is that I actually have a sample chamber with a 2-inch PVC pipe that's capped on one end. And I actually put my transducers on the pipe, fill it with water, and measure the sound speed of water. Now I know that the meter is set up properly because I've got a verification with the water sound speed. I pour that out and I put a sample in that chamber, and it tells me then what the sound speed of that media is. Now I have a direct measurement of the sound speed. So when I go and install the transducers on the pipe, I know what to expect.
Oh yeah, that's a really good pro tip. Thanks for sharing that.
Sure.
Any other questions for John while we have him? Well, thank you, John, for sharing that information. I mean, that with the technology that we've got to offer, it can be an incredible money saver and profit generator for all types of customers with all Magmeter applications where you're considering what has to be done. And you've got our contact information. You can reach out to John or myself. And again, John, thank you so much for sharing your knowledge on this. Thanks for everybody that joined in.
Thank you, Dan. You guys have a great day.